In this algebra video, we're in Chapter 6, Lesson 3. We're going to talk about the elimination method for solving systems of linear equations. This is my little abbreviation for systems of linear equations. Now, I'm going to break this into two parts. This is going to be part one. We're just going to focus on being able to use addition and subtraction. And by the way, as a side note, the elimination method, this is your third method for solving systems of linear equations. We've learned there's going to be three methods total. We already talked about graphing. If you go back and look at that 6-1 video, we've talked about solving with the substitution method. That's going to be in 6-2. And now the elimination method. Now, one more time, we're just going to focus on just using addition and subtraction. In fact, for the elimination method, you always use addition or subtraction, but sometimes you need to multiply first. And we'll talk about that in part two. So that's your perspective. So for now, part one, we're going to keep it a little bit simple. Just talk about the main elimination method. Our objective is, and this is going to be very similar to part two's objective as well. I can solve systems of linear equations using the elimination method because I will look to see which variable I can cancel out by adding, or I cut off subtracting over here, by adding or subtracting the equations together. So basically, we're going to add or subtract our equations together. One of the letters is going to cancel out. That's when you would want to use this method. And then you're ready to move forward from there. All right, here are your steps. And now this little tip I wrote up here, this is for part one. In other words, these are the steps you're going to do when you have a common or opposite coefficient already. A common or opposite coefficient already. Meaning, I'm just making this up off the top of my head. I'm going to write it on top of it real sloppy. 2x plus y equals 5. I'm just making that up. Now, if the next equation is 2x plus, it doesn't really matter what's after that. The fact that you have this 2x in common right here, that means you're ready to move forward. So, or if this has been a negative 2x, that's what I mean when I say a common or opposite coefficient. That's what I'm referring to. Now let's get that mess out of the way. All right, so that's when you're going to use this. And in general, you're in part two in the part two video, I'm just going to show you what to do when you don't already have that. Anyway, let's get into this. Step one is going to be rewrite, if needed, the system so that your like terms are aligned. And now I'm going to jump ahead for 3 seconds. Don't freak out. I'm coming right back. If you look at this example, our like terms are aligned. The x's are over each other, the y's are over each other, the constant term is over each other. That's what I mean by being aligned. Okay, I'm back. Hey, look at that. Now, if they weren't aligned, which is, hey, I'm going to jump ahead one more time. Don't freak out. I'll come right back. Right here, they're not aligned. Notice, yeah, your x's are, but your y's are not aligned. Your constant term is not aligned. So you'll have to reorganize them to get them there. See, look, I'm back. Anyway, now we're going to finish on this page. No more jumping away, so make sure you get this written down. Basically, once you get them aligned, you're going to move on to step two. Step two is, by the way, getting them aligned is just going to be using what you know. How to move something to the other side, back and forth, to put in the order you want. Maybe you want to put it in standard form. Maybe you want to put it in slope-intercept form. That's what I mean, kind of moving the terms around. Once you have them aligned, you're ready to add or subtract the two equations together, and when you do this, it's going to eliminate one of your variables. Now, this is only going to happen if you have a common coefficient or an opposite coefficient. Anyway, once you eliminate one of your variables, you're going to solve for whatever the remaining variable is. So if your x's cancel out, you're going to solve for y. If your y's canceled out, you're going to solve for x. You're going to get an actual number value. You're going to get x equals 4 or y equals 2. You're going to get an actual number. Once you get that number, you're going to substitute that value you just got from step 2, and you're going to plug it into either of the equations, it doesn't matter, and then solve for the other variable. This is kind of like the end of the substitution method, to where once you got a number for one of your letters, whichever one you chose in the substitution method, you plugged into either equation and solve for the other letter. Anyways, once you have your answer, I want you to write your final answer as an ordered pair. Now let's do some examples. Hit pause if you need to finish writing this. Okay, so these are the examples I jumped ahead and showed you. I'm already going to give you a heads up. I'm going to do 2 examples at once. The reason why is I want to do them side by side so you can see how they're going to be the same and how they're going to be different. So step 1 is make sure that your variables are aligned. Well, let's look at our first example. Our x's are aligned, our y's are aligned, and our constant term is aligned. Okay, that's good. When I say aligned, I'm also referring to the equal sign. Now, look on the second example. The x's are aligned, the y's are aligned, and the constant term is aligned. Okay, so step 1's already done for you. And to be honest, in this section for now, I'm going to keep it simple. Most of the time, they're already going to be done for you. But as we get to part 2 and maybe a little bit in this section, and I will give you an example of the video, what to do when they're not in the same order already. Anyway, once in the same order, you need to decide. Are you going to add or subtract? Now I'm going to erase this in a minute. I'm just putting it there so we have a choice. Are you going to add these together or subtract? Remember that your goal is to have a letter cancel out. So take a look at the first example on the left. Number 1. If you were to add these two equations together, you would have x plus 2x. That would give you 3x. The x's wouldn't cancel out. But if you were to add, look at what happened to your y's. You have negative 1y plus 1y. Well, negative 1 plus 1 is 0. So poof, your y's are gone, and you'd be left just with your 3x equals 4 plus negative 4 is 0. Okay, so you'd have 3x equals 0. Divide both sides by 3. I'm jumping way far ahead than I meant to. But my point is, notice one of your letters canceled out. So in that example, you would want to add to cancel out your variables, because we notice that your y's are going to cancel out because they have the same or opposite coefficient. Their coefficient, the top one is a negative one, the bottom one is a positive one. So you're never going to add for that one. Well, for example 2, your common coefficient is common. It's the same. They're both positive 7. So the only way to get two 7s to cancel out is to subtract. So you'll do 7 minus 7, and so you'll get 0. And so I'm actually going to work these out, and I'll show you what I mean. But notice that the coefficients are the opposite, you're going to add of what you're trying to cancel. And if the coefficients of what you're trying to cancel are the same, you're going to subtract. So let's actually do it. Now, I know I kind of already showed the steps for the one on the left, so I'm just kind of briefly work it out. Because your coefficients are different, you're going to add. So you're going to add these two together. X plus 2x, well, remember that's 1x up there, so that's going to be 3x. Negative 1y plus 1y, well, that's going to give you 0. Poof, it's gone for the reasons I said before. So those actually cancel. And so we're going to be left with 4 plus negative 4, well, that's 0. And I'm going to finish the same way I did before. 0 divided by anything is 0. Alright, so we did step 2 in here. We got a number. Now I'm going to do step 2 for example number 2 as well. But for the reasons I already said, we're going to subtract. But now, this is important. This is a common mistake people make. When you do the subtraction sign, I highly suggest you put parentheses around it. So you remember, it's subtract for everything. So 7x minus 7x is 0. In other words, poof, it's gone. Now you have 4y. This is not 4y plus 2y. Remember, this is, it's almost like distributing that negative. This is 4y minus 2y. That's what you're doing here. So 4y minus 2y is positive 2y. Because it's positive, plus sign equals 2, not 2 plus 8, 2 minus 8. 2 minus 8 is negative 6. Anyway, so you're left with 2y equals negative 6. I'm just going to go ahead and erase that 0. We don't even need it. So now divide both sides, you're done. Okay, so now you've done step 2 for example 2. Now, it's going to be just like the end of the substitution method. For example 1, you've got a value for x. All you've got to do is put in for one of these equations, just one, not both, and then see what you get for the other one. For simplicity's sake, I highly suggest you plug into the first equation. Since it has no coefficient, it's less work. So that's going to be 0 minus y equals 4. So you're left with negative y equals 4. Divide both sides by negative 1 or switch, however you want to justify it. You get y equals negative 4. So you have x equals 0, y equals negative 4. Well, that's your answer. 0, comma, negative 4. That's the answer to example 1. That's the location where these two lines cross. That's your solution. Anyway, now do the same thing for the second example. You go ahead and plug in negative 3 into either equation. So go ahead and plug it into either one. They're both similarly just as complicated, so I just plugged into the second one. So now go ahead and follow your regular equation skills and solve this. Plus negative 12, well that means minus 12, so I'm going to go ahead and write minus 12. And solve from here. You get 7x equals 14. I'm out of room, so I'm just going to write the answer. You get x equals 2. So now you have x equals 2, y equals negative 3. Well, that's your answer. 2 comma negative 3. And that is the answer to that example. This is way too messy. I shouldn't have squeezed two examples on the same page. I promise I'll be more organized for this example. But go ahead and hit pause, write this down. But I basically want you to see, look, this is an example where, hey, they're not lined up for you already. So I'm going to give you an example where you need to line them up yourself. So basically, you got to move. You can either turn both of these in a standard form, both of these in a slope-intercept form, or both of them in the whatever this form. That's not really a form with x on the left side. Regardless, line them up however you want. I'm going to go ahead and put them both in the form of the first one. So that means I'm going to manipulate the second one to make it look that way. So we're going to move the y to the left, and that's the only thing we got to change with that one. Now we have them in the same order, so I move it back underneath it. Now, as a brief side note, just so you know, technically, if you didn't line them up first, you could still do your thing as far as how to cancel. You just need to pay attention. Am I going to add to cancel? Am I going to subtract to cancel? So technically, if you don't have them lined up, it's not actually not going to work. It just makes it more messy. And so you're going to end up having a variable on both sides, and just more things can go wrong. But as a side note, it does still work, but you're never going to see me do it. I'm always going to tell you to line them up first. Okay, so let's see who we can cancel out. The coefficient of our x's are both positive 6. The coefficient of our y is the negative 1 up top and positive 12 on the bottom. So clearly we're going to cancel out the x. But the coefficient is the same. And the only way to get those to cancel out is if we subtract, because 6x minus 6x is poof, 0. So that's what we're going to do. We're going to subtract. Now, you're also always going to see me try to remember to use parentheses on this so that you remember to distribute that negative or that minus so that you're less likely to mess anything up here. So now I'm going to go ahead and do that. 6x minus 6x is poof 0, so I'm not even going to write it. I'm just going to put a little slash through it. Now, write it if you want, just whatever you got to do to be neat and organized. Let's move on to our y's. Now, this is negative 1y, not plus 12y. Remember that negative sign in front. So it's going to be minus 12y. So negative 1 minus 12 is going to be negative 13. Common mistake on this question. Now just drop everything down. Well, we still got to subtract. Negative 145 minus 24. Well, that's negative 169. So now finish solving for x, or excuse me, solving for y in this case, since you have y. Divide both sides using the same skills you already have. And negative divided by negative is a positive. Well, that equals 13. So we have y equals 13. So that's step 2. Remember, step 1 was line them up in the same order. Step 2 was now go ahead and do your add or subtract, whatever you need, and solve for your letter. In this case, y equals 13, so we got y. Now step 3 is plug that into either equation, so you can put it in for this one, or you can plug it in for this one. It doesn't matter. Into either one, and solve for the other letter. I'm going to go ahead and plug it into the first equation just because I see y is kind of by itself, not really a coefficient. So I'm going to put it right there in y's spot of the first equation. Now just go ahead and follow your equation skills and get this thing solved. Meaning move 13 to the other side. So honestly you don't really need the parenthesis in this case, but whatever. Add 13 to both sides, divided by 6, you're done. So you end up with x equals negative 22. Well, put all that together and you have your final answer. So I'm going to write it as a ordered pair, nice, big, and proud. The x value is negative 22, so that goes here. The y value is 13. So that's your final answer. That is the solution to the systems of equation. That is where these two equations, these two lines will cross if you were to graph them. Now, as a note, remember we're not jumping into word applied problems just yet. We're going to focus on those more in class. In this video, I'm just trying to help you with your arithmetic. But as far as how to interpret your answers, if this were a word problem, we'll talk about that in class to make sure we can put it in context. But for now, we're going to focus on the arithmetic. You know what it's time for. Example with fractions. You will be fine. What we're going to do, I want you to try this one, but I want you to take your time and work it through and do the same thing you would do. Look to see who you're going to cancel. Okay, with addition or subtraction. Okay, so now do it. Big deal. You got to deal with fractions. Just remember your fraction skills. You need common denominators, which you already have, by the way, and just do the same thing you did. If you're not sure if you can do this one correctly, do it on a scratch sheet of paper. Try it. Then once you've confirmed you're doing it correctly, then do it on your notes. Hit pause. Give this a shot. Alright, so first of all, you'll notice the one coefficient you have in common, the y coefficient is not the same. In this case, the x coefficient is, and they're the opposite. Well, to get opposites to cancel out, you're going to add. Now, you don't have to memorize that. Just ask yourself, negative 1/3 and positive 1/3, what operation would you do to get those to equal 0? In other words, the poof, goodbye. And if you were to subtract, you would get negative 2/3 x. Well, that's not canceling. So you're not going to subtract. You're going to add in this case. So you're adding these two equations together. Alright, so let's see. Negative 1/3 x plus 1/3 x, so that equals 0. So in other words, poof, it's gone. So I'm going to go ahead and, I'll just go ahead and stick a 0 there. Now go ahead and move on to everything else. So negative 4/3 plus negative 2/3. Well, that means subtract. When you add a negative, you subtract. In other words, when you have a plus sign here, you basically can just do exactly what it says whenever things are below it. So in other words, negative 4/3 plus 2/3. Well, that's negative 2/3. Because negative 4, oh, excuse me, I went in the wrong direction. Negative 4 minus 2 is negative 6. So that's negative 6/3. Yeah, don't get so cocky that you forget your negative skills. I can't believe I was saying that backwards. Anyway, moving forward, negative 2 plus 4, well, that's positive 2. So we basically have negative 6/3 y equals 2. Now you just have to remember how to get rid of coefficients. I'm going to go ahead and get that 0 out of the way. It's distracting me. Now I have to remember how to get rid of coefficients. Some of you know the shortcut for doing this. I'm just going to explain it the same way I always explain. To get rid of all coefficients you divide. So we're going to divide by negative 6/3. The only thing is, oh no, you have a fraction, but the truth is, just remember how to divide by a fraction. Simple as that. Well, your coefficients cancel, so those are gone. So you're left with, I'm going to show my work up here, y equals 2/1. Now, how to divide by a fraction? Remember, rational coefficients, go back to chapter 2 if you need help with that. You multiply by the reciprocal. In other words, keep, change, flip. You flip it and multiply. So it's still going to be negative, but now it's going to be 3/6. That's the trick. So now go ahead and multiply this, and you will have your answer. Multiplying straight across, positive, oh, by the way, positive times a negative is a negative. 2 times 3, 6/6. 6/6 equals 1, so we got negative 1. So we have our first y value. Our first y value is our first value, and it's y equals negative 1. Well, once you have that, remember, plug it into either equation to get your other letter. Now, honestly, these equations both look equally kind of fraction-y, so it really doesn't matter which one you stick it in. So I just chose the second one. So put negative 1 into y's place, meaning right here, and now use your equation skills to solve. Negative times a negative is a positive. Now you get yourself a two-step equation. Subtract 2/3 on both sides. Yeah, you'll have a fraction over there. I suggest you leave it improper, and then do the whole coefficient thingy. I'm going to show my work over here on how to do that. And you'll get an improper fraction. This is what I meant where I said leave it as an improper fraction for now. You'll save yourself hassle for this next step because you know you're about to divide by a fraction, so you're going to want it to be improper over there anyways. So now finish it the same way we were just solving a second ago. You get 30/3, which is 10, so x equals 10. So stick your answers together. X is 10, y is negative 1, and you've got your answer. So, big scary fraction example, no big deal. You just got to be careful with your fraction skills. Alright, so we've done a few examples. You're going to practice this, and in part 2, we're going to move on to what happens when your coefficients aren't the same or the opposite. Meaning, let me go to an easier example. Let's see. In this one, instead of having 7x and 7x, what if you had something where they're not the same? And that's basically what we're going to do in the part 2 video. Alright guys, let's come to class prepared, and we'll see you then.